Right, let's dive into this explainer. If you've been building anything with LLMs, you have definitely hit that wall where the model just gets completely confused and starts hallucinating. Well, today we're going to uncover why the true secret to exponential, and I mean literally 10x AI performance, isn't some magical monolithic prompt. It's actually just about breaking things down and giving the AI the mental breathing room it needs to actually reason.
So, why do incredibly smart AI models just totally faceplant on complex tasks? Think about it. You wouldn't walk up to a brand new human intern and fire off a massive 10-part project in a single breathless sentence, right? They'd panic, forget half the steps, and probably mess up the rest. Yet, this is exactly what we do to language models when we cram everything into one giant prompt. They suffer from massive cognitive overload.
Here's our roadmap for today. We're going to cover the AI overload problem, the power of splitting tasks, move into chain of thought, then tree of thoughts, and wrap it all up with safe and secure prompting.
Starting right off with Section 1, the AI overload problem, and Section 2, the power of splitting tasks. When we look at OpenAI's core strategies, what's really fascinating is that while everyone obsesses over writing clearer instructions or plugging in external tools, the real paradigm shift comes from that third point, splitting complex tasks. By decomposing a massive request into a structured pipeline, you drastically reduce error rates, and honestly, you just multiply your model's reliability.
The official documentation actually hits the nail on the head here. It explicitly says, breaking down tasks into simpler subtasks improves accuracy, give models time to think. If you want expert-level accuracy, you absolutely have to force the model to hit the brakes, have it pause, analyze, and process sequentially. You just can't expect it to leap straight to the final answer on a complicated problem.
Okay, but before we can effectively split tasks, we have to organize our communication using foundational .NET message roles. We need clear boundaries. The system role gives the overarching master instructions. The user role is your specific prompt, and the assistant role provides the responses and keeps the conversation history. Setting up these boundaries is step 1 in managing the AI's cognitive load.
Once your roles are set, the next step in breaking down expectations is moving from zero-shot prompting to few-shot learning. Zero-shot is basically making the AI fly blind. Few-shot, on the other hand, gives explicit input-output examples, teaching the model exactly what format you're looking for. It is literally like giving that intern a completed template before you ask them to build out the rest of the spreadsheet.
Moving right along to Section 3, linear logic, specifically chain of thought. So what is chain of thought, or COAT? Basically, it's a prompting technique that forces a linear left-to-right logical flow. Instead of letting the AI instantly guess the answer, the model mimics a straightforward, sequential progression of ideas. You are quite literally telling it to show its work before handing over the final result.
If you compare standard prompting to chain of thought, the difference is night and day. Standard is opaque and instantaneous, which, sure, is fine for simple data lookups. But for math, logic, or complex workflows, that transparent, step-by-step progression of COT is where that 10x performance boost really lives, because it completely prevents the AI from skipping crucial logical steps.
But what happens when the problem isn't a straight line? That brings us to Section 4, branching out with tree of thoughts. IBM's research has a fantastic way of framing this. As they note, tree of thoughts mimics human problem-solving by systematically considering multiple solutions and discarding the ones that are found incorrect. This brilliantly shows how we elevate the AI from a simple linear calculator into a strategic thinker capable of trial, error, and backtracking. If it hits a dead end, no big deal. It just prunes that branch and tries another path.
To actually make this work, breaking down a monolithic prompt into the tree of thoughts framework requires 4 distinct, manageable steps: thought decomposition, thought generation, state evaluation, and the search algorithm. These 4 pillars are basically our ultimate task-splitting engine. Let's zoom in on how the AI actually generates these thoughts in step 2.
What's really interesting here is the contrast in that thought generation phase. You can instruct the model to use sampling to generate multiple, independent, diverse ideas, which is absolutely perfect for creative brainstorming. Or you can use proposing, which generates thoughts sequentially, where every step strictly builds on the last one. That's ideal for logic puzzles where you really need to avoid duplication.
Now, to ensure the AI stays on track, it has to evaluate its own split tasks. It can assign a hard numerical value, like a rating from 1 to 10, to judge a thought's potential. Alternatively, for more subjective things like creative writing, it can use a vote evaluation. This just compares different solutions and selects the most promising path forward based on overall quality. Finally, the AI uses a search algorithm to navigate these split tasks. It can sweep across all immediate options horizontally using a breadth-first search, leaving no stone unturned at the surface level. Or it can dive deep down a single rabbit hole using depth-first search, exploring one branch entirely and only backtracking if that specific hypothesis turns out to be totally invalid.
And the proof? Well, it's in the results. Just look at these benchmarks. By utilizing this deep task decomposition, models went from completely bombing to mastering notoriously complex challenges like Sudoku, the strategic arithmetic game of 24, and even 5x5 crossword puzzles. The 10x leap in performance happens because the AI can finally recognize its own dead ends and course correct, instead of just stubbornly hallucinating a completely wrong answer. Okay, time for a quick reality check though. We have to acknowledge that this 10x improvement is not free. Tree of Thoughts requires heavy computational resources, significant memory overhead, and carefully structured prompt implementations. It is a genuine engineering marvel, which leads us directly to our next, highly critical point. Which brings us to Section 5, Safe and Secure Prompting. When you invest time into splitting tasks and building these detailed, highly complex tree of thought frameworks, you are creating incredibly valuable intellectual property, and adversaries absolutely want to steal it. A fascinating research paper recently outlined a framework called P-leak, or prompt leaking. This is an adversarial attack where bad actors incrementally extract and steal your proprietary system instructions.
So how do we lock it down? To protect your AI, you must apply cybersecurity principles directly to your prompt text. Use strict imperatives instead of vague directives. Isolate volatile user inputs using XML tagging, and construct defensive sandwich layers where your security rules wrap completely around the user's prompt. Security is no longer optional, guys. It is a fundamental part of the prompt engineering process.
All right, let's wrap this up. Summary: the 10x mindset shift.
Here are your core takeaways for this explainer. The overarching lesson is really a mindset shift. Stop trying to write the perfect, monolithic magic bullet prompt. Manage your AI exactly like you would a human intern. Decompose the workload into structured subtasks. Using techniques like chain of thought and tree of thoughts gives the model the time and space to actually reason, which reduces cognitive load and drives that 10x leap in reliability. And always secure your instructions. Armed with this framework, I want to leave you with one final question. What massive, frustrating project are you finally going to conquer by breaking it down for your AI today? Start splitting those tasks, let the model think, and watch your results multiply. Thanks for diving into this explainer with me.